Okay, let's get things set up real quick, and then we'll see if Phil can join or not. Okay. Let's make sure we're in a good running state. Okay, let's just test this out real quick. Let's make sure we're able to reproduce jitter. Okay, so I'm not really moving, but you can see how the joints are bouncing around. Like, it's continuously trying to guess where the joints are, and it's having a difficult time. Now, there's things that could improve this, but like, if I was wearing extremely tight clothing, like, it would probably be able to do a better job at figuring out the joints. But for our use cases, this jittering makes everything difficult, because what we're trying to do is validate the user's body position based on it, right? And so, like, right now you can see the legs are flickering. That flickering of the legs is because we're, like, very close, but it's a side effect of that jittering also. And it just doesn't feel good and consistent at the app user experience. So the goal is to figure out how a way to minimize or eliminate that jitter joints. Okay, so like let's see. Okay. All right. Okay, things are set up. So let's do another marker real quick, which is explain joint jitter issues. That didn't work. I got this. Okay. Okay. So here we're running an app that's running the SDK, and it does body detection. So it's doing joint detection. We're using MLKit to facilitate that. And so MLKit is sending us all of the landmarks, which is what you can see, these white dots that touch my wrist and my elbow. We're filtering out a bunch of those that we don't care about. But like, we're using these to try to build the UI to facilitate getting the user's body into the correct position so that we can capture images of it, and then those can go through to the computer vision pipeline to actually generate a 3D model representation of the body, right? Okay, and we've done this in iOS already, and so we're now building this Android SDK. Of course, there are things that are slightly different, so we can't just port the code over, which we've largely done to some extent, but like things behave differently. So like iOS, for example, you'll see all of these dots. I'm not really moving, but the dots keep moving. So MLKit just has this like jitter where the positions that it's guessing for the joints, it's not guessing them the same way consistently every time, and therefore things jitter quite a bit. Okay? Now this has some issues with jittering, like you can see my legs flickering off and on, okay? Like that's because my legs are like close but not quite close enough, right? And the jittering causes them to flex back and forth. Now, there's two things that can address that. One is our algorithm for actually vetting whether or not the user's body is in the correct position, which is like looking at their legs, make sure their legs are extended straight, and that the angle between the legs and the torso, same thing with the arms, right? Like, if we tilt our torso, we can see our torso's not right. So like, it could be that algorithm, but a big piece of it, which is also affecting other things, like the basic validation, etc., is like, my theory is if we can solve some of this jitter and create a more stable positioning of these joints, that would help solve a number of our problems. So that's the thinking, and that's what I'm trying to focus on in this section. So let's dive into the jitter issue. Okay, so to tackle this, I've been thinking about this a bit. I've been doing some research on dampening algorithms and convergence algorithms. None of them so far that I've found really fit appropriately. So I think I want to start with something just simple. Like, if we do some sort of like windowing of joints, so like imagine my left ankle, right? If we had a window where we collected the joint positions over time for my left ankle for, let's say, 10 points, 10 points in time or something. I have no idea if 10 is the right number. I'm just pulling something out of thin air, right? But if we say we collect those 10 points as like a moving window and we compute the average of those 10 points, does that give us a more stable result? That's the question, right? We could start with something that simple, and I think that's what we should do. But maybe to start, we just collect positions via log, and we throw them in a spreadsheet to see if we can actually plot this in a spreadsheet and see how it would work before we even bother to wire up the coding. Okay. So let's go to... It's the best place to do this. I mean, we could do this in the frame distributor even. We could probably do this in the frame distributor. The frame distributor distributes a frame, and that frame has landmarks in it. So we need to, what listens to the frame distributor? A picture's worth 1,000 words. All right. So we got our pose validator, position validator, level validator. So we got our pose and position validator are the two main ones. So let's go. We don't want frame distributor, but we want the next layer up. So we could do pose. Let's do pose just because we're there.
pose validation, pose readiness, pose problem, pose readiness distribution. This listens to readiness, which is mutable share. Send to that. Okay, and then validation, validate pose, takes in the frame. Yes, okay. So, landmarks to bones. Normalized landmarks turns the normalized landmarks for a frame. Get width. Okay. This normalizes them into a percentage relative to the height of and width. Okay. Okay, so we have our landmarks here, but we're going to want to do a specific one. Bones is empty. Do we want to get? What is this exactly? It's just an array. It's just a list of posed landmark and posed landmark. Posed landmark is a thing that has a posed landmark type. That's private. Get landmark type gives me that integer. Okay, so let's like pick like left ankle or something. If we get a landmark here, we want to filter this down till it dot landmark type equals pose landmark left ankle. Okay, and then we'll just say like val left ankle landmarks. Should only be one. So let's just do a log.w of true left ankle landmark. Okay. And then we're gonna give it left ankle landmarks. I guess we'll do position 0. Position. Doesn't it like unnecessary safe call? Really? That seems concerning to me. Get. Okay, well, apparently there's no check for that, so if left ankle landmarks is not empty, then do this. Left ankle landmark, and we'll do take a landmark. It's empty. Okay. Okay. Let's do this. All right. Let's go back here. Let's get some logcat. Let's delete this. Let's restart. Sweet. Let's get this back up and start a new recording. Continue. All right. All right. Let's hit stop. Okay. So we got some data. Okay. Kind of think we should grab some of the data from the middle. I don't know. Let's start with that. Okay, let's go open a Vim session. Let's paste all this shenanigans in here. Okay, we can get rid of that. Let's do %s close. What do I want to do? No, let's do. What do I want to replace it with? Nothing. Why are those the only ones that match? Strange. Followed by carriage return. Huh. What do we got going on over here? Why are those not match? %s. Can I do digit? I can do 0 through 9. Let's do 0 through 9. Why is it only searching up to there? I do not understand. What am I missing here? Well, we can use... okay, so let's go here. Let's just $X. Okay, let's just do $sign X escape. How long have you been in tech industry? A long time. Over 20 years, probably. Here, let me see. I'm not good with time. Resume. 2000? Since 2000, I've been professionally in the tech industry. So we're at 2024. So 24 years. Oh, man. I feel old now, MadLab. I feel old, MadLab. It's, why is... I'm a lot more senior than you. Well, 24 years. How long have you been in the industry? Third year of my graduation and working with a startup. You're in your third year of your graduation. What does that mean, you're in your third year of your graduation? Does that mean you're your third year of school, of college? And you have one more year left, but you're working with a startup already? Or does it mean 3 years after you've finished school? Not what I wanted, is it? Dude, why does it keep resetting to this? Nobody wants the folders like that. Oh, that did not do what I wanted. What the? I'm in the third year of my graduation and working with a startup. Oh yeah, only 1 year left of college. Gotcha. Where do you go to college? Download as export file. What the heck did it do? Come on. Come on, Google. Nothing? Didn't do anything? Oh, there it goes. It just took it a while. Okay. Okay, we got some points now. Okay, now we gotta make a chart. I gotta remember how to do charts. It's been so long since I've used something like... Okay, what are we doing here? This is going to be PrismLabs joint jitter exploration. Okay. Oh yeah, you're from India? Oh, cool. Is the tech scene pretty big in India now? A1 to A88, B1. How do I want to represent this is the question. Maybe it's best to think about this on 2 axes. Let's insert a row above. Let's just say this is X. And this is Y. I don't want versus X series. I mean, I really do want 2 axes. Seems like I should be able to add the other series. Alright, let's change this. A lot, but most of the devs are stuck in this tutorial hell. Interesting. Yeah, there's like... learning coding is interesting. I learned coding back in the day before we had all these tutorials and all of this stuff. So I didn't get stuck in that trap really. I just had to go through the hard path of, you know, like getting books and reading about assembly and C and computers and kind of doing that stuff on my own at the beginning, and making progress slowly on those paths, but doing so gave me a lot of advantage over people that are learning from tutorials, right? Like I had to learn things about like the architecture of computers, how computers are made, how memory management works, like all kinds of things that a lot of people just running tutorials, learning Python or super high level languages don't have any of that context and knowledge initially. That's not to say they can't gain that knowledge. I just think it's a different place to start and it makes certain things a lot more difficult. So it's like when you start at that high level, it's like, okay, you might be able to make one particular thing work because you were able to follow a tutorial. And it might let you solve problems very similar to the tutorial that you followed. But there's like a next level of depth that you need in terms of building context and understanding things. And I think that having that core fundamental understanding is the key to being able to like unlock all these things. Like, why am I able to be a polyglot and work in so many different languages? it's because I have a solid enough core understanding of those underlying technologies and languages to understand what should exist in these other higher level languages and what the backing underlying kind of things are. Yeah, so it's interesting. It's definitely, I think the tutorial world is nice for some things, but horrible for other things. Like, and people need to learn that they need more than just tutorials. They need to like actually go research and study and you know, understand how computers are architected and figure out all these different pieces of the puzzle. I do not want a line chart. Let's do a scatter chart. Okay. How am I going to represent this now? I don't think there's a better chart than a scatter chart, really. Scatter chart, what is this guy? A bubble chart? A bubble chart doesn't really help us. It'd be nice for grouping things. Candlestick chart? No. I think, would this radar chart help? I don't think the radar chart will really help. I think what we want is this scatter chart, but this is the timeline. So we have our X coordinate here. We have our Y coordinate here. So what's interesting is the Y fluctuation is pretty low. It seems like, at least on these scales. Let's try something else. Let's do like an average X, average Y. Let's just do a total average. So this is going to equal the sum of what was it, 80 something? 83 divided by length of string? No. Whoops. 83 minus 1, so 82, I think. If that's right. I'll do the same. Sum of the the most interesting part, understanding the core fundamentals will give you a lot of edge. But if you will see, most devs in India start with easy things without making their core strong. Yeah. I don't think it's limited to just India. I mean, I feel like that's happening more and more in the US as well. Like more and more US developers that I meet and interact with, they've learned that way, right? Even ones that have, like, I don't quite understand this. Maybe it's because, like, maybe college is different now than when I went to college, but I don't know. Like, there's people I meet that went to college, and even in, like, software engineering or computer science degrees, and, like, they don't have good fundamentals either. So it's like either they didn't pay attention at all, or the computer science course work is different than when I went to college. Because when I went to college, they like made me do all of the different kind of core fundamentals. Like, we wrote compilers and languages and learned about all of that stuff, as well as like had computer architecture and computer engineering courses, and like where you had to learn about how computers were actually built at a lower level. We had like full classes that were just straight assembly that we had to learn and write assembly in. So it's interesting. Let's add a series. Do I want to add a series? Let's increase this to D83. And then we'll add a series, which is going to be average X. Alright, so that's where that would get us. How do I want to do this? What's the best way to do this? Okay, so if we were simulating this algorithm, or doing it manually kind of in here in the spreadsheet, let's get rid of this average Y. Okay. I don't know where we're going to put this. Over here somewhere. Let's put it over there somewhere. Okay. So if we're to do this at the beginning, we would have sum of, let's do X. So we're going to do sum of this divided by 1, which is just going to be the same thing as what it is. Okay. So that's a useless. So let's do A2 to A3 divided by 2. If we do that, then what I'm wondering is if we do sum of B2 to B3 divided by 2. No. Don't autofill that because I don't think that's what I want. Maybe this should be down 1. Okay, and then this should be equal to sum of the first 3 divided by 3. And this should be equal to sum of the first 3 divided by 3. Okay. Okay. Now if we had that, if we add series, or let's label these. Let's do average X, average Y. How can I tell? How can I tell with this chart if what I expect is that this is, yeah, that's the 118, 117, 115. What happens if I extend this down? 2, 5, A2, 6, A2, 7, A2, 8. We need to find out. You have so much experience. What will your best advice to me to differentiate myself from others, which will help me in the long term? I mean, I have only 7 months experience in tech industry and I don't know much about it. That's a good question. I mean, it depends on what like area you want to focus on. Like, what kind of stuff do you want to do? Like, do you want to do like graphic stuff? Do you want to do web design stuff? Do you want to do native mobile app development? Like, what kind of stuff do you want to do? Google Sheets do a running average. Create a formula to calculate a 7-day moving average. To do this, select the cell where you want the average to appear and enter the following. This formula will calculate the average of the data in the range of the cells from A1 through A7. Rolling average. We can use the average function to calculate the running average, or we can say the moving average, MA, in Google Sheets. MA is constantly updated average value. Please note the simple moving average is different. SMA is the average of a given set of values over a number of days in the past. Since running arithmetic mean average requires repeated calculations, we may be required to use more than one average formula. There are functions like SUMIF, mmult, and daverage that we can use to write running average array formulas. You want to do full stack or basically web dev? Like, I mean, like, full stack is like a super generic term that everybody uses today. So it's like, if you're saying you want to do full stack, meaning you want to do like front-end native mobile app development, or like cross-platform mobile app development with something like Flutter or React Native, and then you also want to be able to do the backend APIs that facilitate that. And then beyond that is like the DevOps, the like layer beneath that is like how do you host that on infrastructure, and that's where like infrastructure as code stuff comes into play and DevOps stuff comes into play, interacting with AWS. And then there's, of course, like the next layer down from that, which is like actual system administration, which is a whole nother thing, which is like running Linux servers. Yeah, it's like, where does full stack stop and start and end? Like me, I've done all of those things. So I'm pretty comfortable with most of them. There's things that I did longer ago, like system administration stuff. I do that personally still now on machines that I manage, but I don't do that nearly as much as I used to, because nowadays there's like cloud hosted computing platforms and things like that. So now more of that stuff has shifted into kind of infrastructure as code. So I do more of that for that stuff. But there's people that have the entire careers focused on like just doing AWS and like infrastructure as code. But yeah, so it's like, how do you define full stack? Is it like you want to be able to build the front end of the application and the back end of the application, and you want to be able to like, generally building a back end also requires interacting with some sort of database, whether it's a relational database or a columnar data store, or some NoSQL data store. You also like generally interact with like, you know, some queuing systems or Kafka or like other platforms for sending data back and forth. But yeah, you can't start with the whole pie, right? So like when I started, well, my career actually started in network security research and development. And so I was like deep into the networking space and working on like reverse engineering network protocols, and, you know, evaluating exploits and things like that, which was low level programming stuff. So that was a lot of C and assembly. And then I was doing like proof of concept research and development for stuff for the government, for the NSA and the DoD, and did that for a while. Used C++ and Python and a few other things to facilitate that, as well as, you know, SQL databases. Also built like a web application there. So that's like, so I kind of started low level like code stuff, just like applications, did some like desktop application stuff in Windows, and then moved to backend services and networking, then did some web app development, went back to like desktop stuff for a bit, did more web app development. And this is when like we were doing full stack web development, right? There was no separate JavaScript front end. Like we did the front ends on the back end and then sprinkled JavaScript in. And then shifted to building APIs and front end JavaScript framework stuff for web, and did native iOS and native Android and desktop, macOS desktop stuff, and then cross-platform stuff as well, cross-platform mobile. But that's like all over years and years of time, right? Like I started, you know, with low-level computing stuff, but that's just where I started. Like you just gotta pick somewhere. Like if you want to start with backend, then start with backend. And be like, cool, I can do backend. And when you hit those boundaries, like you could step out of those boundaries a little bit and be like, oh, I want to go make a UI for this. Like you'll learn some stuff. Doesn't have to be that you're a professional front-end developer to step into that world. Like, you could just be doing backend for your career for right now, and then learning that kind of on the side or whatever. Calculate it using the below average formula. Divided by 4. Average data set, single number expressing a central value. We can get this value by adding up all the numbers in the dataset and dividing it by the count of the numbers. Assume the number of employees who have attended the past 4 weekly meetings in our office is 5446. Average equals 5446. 19 divided by 4. Why is that divided by 4? Because there's 4 of those divided by 4, and then that's 19. That's 11 plus 8, 19. 19 divided by 4, 4.75. Calculate it using arithmetic means it's supposed to change when the weekly meeting will be held next week. Imagine the number of employees who attended is 5 this time. Why is it? It's doing the sum and then the division, which gets you 24, but then why is it divided by 5 again? What are they trying to compute? We can get this value by adding up all the numbers in the dataset and dividing it by the count of all the numbers in the dataset. Yeah, that's just this, though. Assume the number of employees who attended the past 4 meetings in our office is 5, 4, 4, and 6. So those are the number of employees that attended the meetings. So 19 employees divided... Oh, I see what they're doing. Yes, that's correct. How to calculate the running average. We can use 2 types of formulas to calculate the running average in Google Sheets. Yeah. You should start, if you haven't already, I would start building just like backends. Start building fun things. That's how I learned like everything, is like just go build projects for fun. For the following dataset, the datasets of weekly meetings are in column A and the number of attendees is in column B. Calculate the running average in the Google Sheets. We can use the below formula in cell 2 and copy paste it down by dragging the fill-in handle. This seems like what I want. The formula will ignore any blank cells in the range B2 but will count 0. Running or moving average using array formulas. If you have 4 running average array formula examples in your Google Sheet, you won't see the 4th one in the screenshot. It's a lambda formula, which I added later. In a small data set, all of them will work exceptionally well. But the 1st and 4th running average array formulas are better at handling large data sets. It's just up to you to pick. Non-array running formula, array formula. Well, let's start with the simple non-array formula one. So we're just going to do we're going to say that this is equal to average of A2 through A3. Okay. Boom. and be equal to average, no, average of, no, why? We're gonna do $B, $2, $B, $B2, $2 to B3. That looks right. Yeah. Okay. The distribution looks... That distribution looks quite similar. C3 to D83. C3 to D83. No, we don't want a column chart. All right, I gotta pee. I'll be right back. All right.
Can you see me breathing? Standing here without you. I can see it's midnight.
Okay, what are we doing now? So if we look at this,
Hiding in the darkness.
so we can see that vertically,
I've been feeling
vertically, it's much more settled on the y-axis. There's much more consistency. It's much closer than it is here. I wish I could see this. How can I see this visually over time? How can I see this visually over time? Maybe I don't want to see it visually over time. Maybe they need labels. Can I add labels?
Can you see me breathing? Standing here without you. I can see it's midnight. I cannot live without you. I'm terrified to see
I don't know.
hiding in the darkness.
Google Sheets do a column of incrementing numbers.
Too close, too much, too far.
Number increment in Google Sheet formula.
I'm yours, you're mine. Too far.
That's ridiculous. Solution that's independent of starting rate. Incrementing integers, 0 base. The values will be 0. I don't care what they are. Row minus. What is that? Sure, let's do it. Boom. Okay, so we got that. Now, can we label them? That is the question. Can I get labels going on those values or something? Setup. Series, X series. Switch rows and columns. No, use row 1 as headers. Use column A as labels. No, I don't want column A as labels. Let's do through E. Okay, and then how do I add labels? Axes and axes titles. Legend. Position, auto. Series. Grid lines and text. Let's just do insert column to the left. Time. Okay. Let's just okay. Use column B as labels. Let's add a series, which is time. Oh no, let's do A1 to C83. This first one. So we have time. X-axis. Use column B as labels. Not sure what that means. Use column B as labels. Use column B as labels. As labels for what? This seems like it plots the X and the Y on there, like it did before. Use row 1 as headers. Yes, row 1. But why column B as labels? It doesn't seem right that unless column B is, it's using those as the labels for the y-axis. I guess it's just treat labels as text. Yeah. Yeah, how do I get it to draw what I want? I want the X. If I say don't use that. So let's add X. Then it takes use column B out of that. That's, if we make time, then we have time going. That's not a useful way to look at it. I think it's easier to see still just like this. It's a little frustrating that candlestick. Open, close, high, and low. Yeah, that's not exactly what I want either. The scatter is the closest to what I want, I think. Add ID. Select range. It's going to be A2 to A83. Why is that an invalid ID? It's a unique number. It's not useful. Not useful. This is useful. Okay, well, we can see doing the running average does normalize things on the y-axis. It also seems to, like, we have these outliers here, but it also seems to then normalize things on the x-axis. Now, where exactly does it normalize them into? Because there's still a decent amount of x-axis going on, but the other thing is we're going to do this in a window, so we're only going to have a windowed thing. I think we might just have to do it and see. I don't think we're going to get a better feel for this, but maybe this is enough of an indicator that it'll help.